Hi, my name is Kiran Baburaj and welcome to Career Campus Pro YouTube channel. We all have spent ridiculous amount of time in queues, but unlike us, our computer actually loves queues. Today we are diving into the widely exciting world of queue data structures. In a queue, we know that the person at the front served the first. So we understand the most fundamental queue principle, first in, first out, FIFO. So queue is a linear data structure that follows the first in first out principle where elements are added at the tail and removed from the head. So every queue has two main parts, the head where the items leave and the tail where new items join. Alright, now let's examine three fundamental operations in the queue data structures. First one is enqueue. This operation adds an element to the tail of the queue, expanding the structure to accommodate new data. Next is dequeue. This operation removes the element at the head of the queue, allowing for the sequential processing of the data, just like getting served from the queue. And finally, the peek. This operation views the element at the head without removing it, enabling the inspection without a modification. Alright, while the basic queue is remarkably useful, several specialized implementations address specific computational needs. So the different types of queues are symbol queue, circular queue, priority queue, double-headed queue. First is the symbol queue that we are discussing so far. It follows the FIFO principle and new elements are always added at the rear or tail of the queue. And elements are always removed from the front or head of the queue. Next we have the circular queue. We notice that the elements A, B and C with a crucial difference. There is a curved arrow connecting the last position back to the first. This circular structure has three advantages. It is more memory efficient as it reuses the space, and the last position connects directly to the first, forming a continuous loops. And it is typically implemented using the fixed size array, making it ideal for embedded systems or memory constrained environments. Our third variant is priority queue. Unlike the standard queues, a priority queue organizes elements based on their priority level, not just their arrival time. As you can see, we have elements labeled high, medium and low, each with their priority indicators. Higher priority elements are served first, regardless of their arrival. They are often used in the heap data structure for optimal efficiency. Finally, we have the double-ended queue. The double-ended queue is the most flexible queue variant, allowing the operations in both ends. And notice the bidirectional arrows on the both sides, indicating the dual access capability. We can insert or delete elements from both ends, providing the maximum flexibility, and they are significantly more versatile than similar queues, supporting both FIFO and LIFO operations. They have applications like undo functionality in software, palindrome checking, implementing both stacks and queues with a single data structure. So let's summarize. The symbol queue, it's a classic FIFO implementation and perfect for ordered processing. Circular queue, they are memory efficient and ideal for fixed size cyclic operations. Priority queues, serving elements based on their importance rather than the arrival time. And the double queue, offering double-ended flexibility for complex algorithmic problems. So queue serves as a backbone for numerous critical systems such as print job management, CPU task scheduling, network packet processing, web server request handling, BFS implementation and all. Finally, let's analyze the performance. The efficiency of queue operations is the key to its widespread adoption. All the operations enqueue, dequeue, peek, isEmpty all has the constant time complexity. This consistent performance profile makes the queues ideal for time-sensitive applications. I hope you enjoy the video Like, share and subscribe for more videos on DSA. Happy coding. Thank you.